This is a review of Chapter 6, Section 6 on complex numbers and trigonometric form of complex numbers. The first thing that we're going to look at is multiplying and dividing complex numbers. If I've got a complex number z1 and a complex number z2, I'm going to multiply those. So that would be z1, z2 is just looking for the product. And I'm going to multiply the real part here, 2 times 3. And then to multiply the rest of this times this, hopefully you recall that we are going to add the angles. So I'm going to do pi over 4 plus pi over 3. So that will be cosine pi over 4 plus pi over 3, and then of course that angle will just repeat with the sine, and we'll need a common denominator, and we'll just add those two angles that are in radians. So that's going to be 12, 4 over 12, and 3 over 12. So I have cosine 7 pi over 12, I sine 7 pi over 12, and we can probably just leave it like that. If we want to go further, then it could be a calculator key. And if I really wanted to push you and be strict about it here, I could say, well, we know the rule for the sum of the sum formula and the difference formula for cosine and sine, and we could do that, but more than likely you'll just leave it like that, or it would be a calculator key in, and I'd probably tell you to do it to 4 decimal places, something like that. All right, now let's do z2 and divided by z1. So this is a division problem, and then I divide the real parts. So I've got z2 over z1, which is going to be 3 over 2, and I am going to do cosine of, z2 is pi over 3, so pi over 3 minus pi over 4. And then we'll get the common denominator and combine those. So I've got pi over 3 minus pi over 12, that's 4 pi over 12. Pi over 3 minus pi over 4, that's 4 pi over 12 minus 3 pi over 12, so pi over 12, right? And that is that. Okay, then we'll go to DeMoivre's theorem. Up here, you see, we're going to recall that. DeMoivre's theorem here. And what is that? That's going to be, let's take and let me erase this, and so I can set up for DeMoivre's theorem, and that's going to be z to the 4th. Let's go z to the 1st, or z1 to the 4th power. So I'm going to take z1 and repeat that here, and I'm going to raise it to the 4th power. So DeMoivre's theorem says raise the real part to the 4th power. So that's 2 to the 4th. And then hopefully you recall that we multiply the angle by the power. So it's just pi over 4 times 4, which will give me pi. If I said use DeMoivre's theorem and simplify, in this case that would be pretty easy, right? So I know that cosine of pi is -1 and the sine of pi is 0. So I could simplify this to -16. And that is a review of that. So this is section 6.6, as I said. And then the other part of 6.6 was the roots of unity. And I don't even know if your textbook uses this. So let's look at how we're going to do that. I am going to begin, hopefully you would know at this point that the very first step in this is to convert this negative 729 to trigonometric form. So I'm going to take and look at that on a real imaginary axis. This is the real axis, this is the imaginary axis, and negative 729i would be, say, down here. So I'm down here at negative 729i. The magnitude is simply the distance from the origin, which in this case is 729. And then I want the angle, which I measure from standard position as if it were a unit circle, this way, and that's 270 degrees. This is the trigonometric form of negative 729i, and I'm warning you that the error that students make is they somehow want to work the negative in here, but there is no negative here. This is an absolute value. It is just the 729. From here, remember that we're looking for the sixth roots. So that would be this, the sixth root, right? But I'm going to write it as a exponent in rational form. So I'm going to write it to the 1/6 power. And then I'm just back to DeMoivre's theorem. So 729 to the 1/6 you would be able to find is 3. And then DeMoivre's theorem says multiply 270 times 1/6 here, and that would be 45 degrees. And that would be the first of the 6 roots. The other roots are evenly spaced around a circle. So I make a different circle here, down in the left-hand corner. And I say my first root is here at 45 degrees, and the other 5 roots, they're evenly spaced. So if I'm going to fit 6 roots in 360 degrees, they're going to be 360 divided by 6. They're going to be 60 degrees apart. So if I just draw those kind of quickly here, they'd be here. This is 65 plus 60 is 125. That was not. I'm not starting at 65. I'm starting at 45. 45 plus 60 is 105, and then plus 60 is 165. Plus 60 is 225, plus 60 is 285, and plus 60 is 245, or 345. And then I'll just convert all those into the trigonometric form, right? There's 1, 2, 3, 4, 5, 6, and each of them just gets one of these angles that I wrote here. Cosine 105 degrees plus I sine 105 degrees, and so on. All right, so there are the 6 roots. Now, when this question is asked, there could be 3 things that could be asked. You could be asked for the roots, so here they are, the 6 roots. You could be asked for the graph, to graph the roots, so here that is. And then you could be asked for the roots in rectangular or standard form, and that would be just taking these and expanding and simplifying. So I'm not going to do that, but that would be the third way that you could be asked for the 6 roots. And that is a review of 6.6. Okay, one more thing here. There may be a correction back at Z2 when I did Z2 over Z1. You want to check, not Z squared, it's Z2, what was it? Z2 over Z1, and that would have been 3 over 2, and then it would have been cosine of pi over 12, and it seems that I might have done minus sine, I sine of pi over 12, and if I did minus, that's incorrect. It should just be plus I sine of 5 pi over 12. And that is the end of the review.